welcome back to my YouTube channel, and this is Kasaligan Vlogs, and today we'll talk about trigonometric substitutions, and this is one of the topics of integral calculus. So what is trigonometric substitution? A change of variable involving trigonometric function is called trigonometric substitution. This type of substitution is particularly useful when an integrand is rational function of u and one of the following radical expressions. So I got this one in Peterson book. For each of these radicals, we use a substitution indicated. So the square root of a squared minus u squared, let u is equal to a sine theta, and so on. So these are the trigonometric substitutions that we're going to use. But it is clear that each of the above substitutions reduces the corresponding radical to the following rational trigonometric expressions. If you're going to look at, so if we have here a squared u squared in this format, we have here the corresponding value, which is a, the absolute of cosine theta, because this is acute, okay, acute angle. So we have here a squared, this is plus, rather this is plus, okay, this is plus. So a squared plus u squared, let u is equal to tan theta, a tan theta, and u squared minus a squared. Again, this is plus, okay, clerical error. Okay, so let's have example number 1. So the integral of x squared dx, the square root of 4 minus x squared. So by the use of trigonometric substitutions, all these parts will be substituted using trigonometric forms. Alright, so we have here the form of this part is the square root of 4 minus x squared. We can have u is equal to a sine theta. So by the way, what is our a? Our a is equal to 2 and u is equal to x. So therefore, when u is equal to x, so x is equal to 2 sine theta. So now, we need to find the value for our x squared dx and the square root of 4 minus x squared. Since we don't have yet x squared, we have to square this part. But before that, we find first dx. So what is our dx here? So our dx here is 2 cosine theta d theta. Alright, so to find for our x squared, so we have to square all the terms. So we have here x squared is equal to 4 sine squared theta. So in this case, we have here the rule that the square root of 4 minus x squared, it is in the clear substitutions. We're going to simplify this one. So the substitution here is a cos the absolute of cosine theta, because this is acute. So what is our a? A is a 2 cosine theta. So now we have here the value for our 4x minus x squared and 2 cosine theta. So we have x squared and dx. But before that, I will explain to you geometrically and how we could be able to use 2 cosine theta. 2 cosine theta here is like this. Okay. If this is our theta, using the trigonometric relations here, so sine theta is equal to x over 2, right? Okay. So a sine is equal to x over 2, so opposite over the hypotenuse. To find for the value for our third side, okay, the adjacent side of the theta here is c squared is equal to a squared plus b squared. So therefore, this is the square root of 4 minus x squared. So in order for us to find the value for our square root of 4 minus x, so what functions that we're going to use? So the function is dapat, we have to use the pair adjacent and hypotenuse. Do not use x, because we could not simplify and we could not find the square root of 4 minus x squared here. So to find for this part, so cosine theta is equal to the square root of 4 minus x squared adjacent over the hypotenuse, which is 2. So to cross multiply, we have 2 cosine theta, is equal to the square root of 4 minus x squared. So this is this geometric explanation to this one. Okay, geometrically, so this is the explanation. Okay, so we have now the 2 cosine theta. So let's substitute here. So x squared. What is the value for x squared? We have 4 sine squared theta d theta. And what is the value for 4 sine squared? I erase this part. And the value for our dx is 2 cosine theta d theta over the value for our square root of 4 minus x squared is 2 cosine theta. So cancel this part. Okay, cancel. So we have here 4 the square root of integral of x sine squared theta d theta. So by the use of transformation, we could have 1/2 minus 1/2 sine 2u. So by the use of this one, we have 4 the integral of 1/2 minus 1/2 sine 2 theta d theta. So we have to simplify for 1/2 times the integral of d theta minus 4 times 1/2 the integral of sine 2 theta d theta. So this is 2, cancel this part, the integral of d theta minus 2 the integral of sine 2 theta d theta. So our u here is 2 theta, our du is equal to 2 d theta. So we have our nf is equal to 1/2. So therefore we have 2 theta minus 2 times the nf, which is 1/2. What is sine theta? Sine theta is equal to cos, or rather this is cos. Okay, cos, and this is cos 2u, and this is cos 2 theta. What is the integral of cos theta? The integral of cos theta is equal to sine theta, then plus c. Again, this is 1/2 1/2 cos 2u. This is 1/2 minus 1/2 cos 2u, which is cos theta rather. So 1/4 2 theta integral of d theta is equal to 2 the integral of cos 2 theta d theta. So what is the integral of cos 2 theta, which is sine 2 theta plus c. So take note of this one. This is our u and nf. We have cancelled this part. So 2 theta minus, what is the identity for sine 2 theta? The identity for sine 2 theta is 2 sine theta cos theta. Again, this is sine theta, 2 theta plus c. So 2 theta, how to find the value for our theta? Using these trigonometric functions, we have sine theta is equal to x over 2. So theta is equal to inverse sine of x over 2. Okay, so therefore, the value of is inverse sine of x over 2. Minus 2, then what is the value for our sine theta, which is x over 2? Our cosine. Our cosine is, you have to equate this part. Here na lang, here. Equate this part. So, divide. So, the square root of 4 minus x squared over 2, then plus c. So, 2 inverse sine of x over 2 minus 2 times x the square root of 4 minus x squared over 4, then plus c. So 2 inverse sine of x over 2, cancel this part. So you have minus x the square root of 4 minus x squared over 2 plus c. Alright, so we come up with this answer. Okay, so I hope nakasabay po kayo. Okay, sorry for some clerical error or mistakes. Okay, I just uh, reevaluate this one. Okay, so number two. So in number two, so we have to find the value of trigonometric substitutions. We have to find for dx, x, and the square root of 9x squared plus 4. So first is we need to look for the trigonometric substitution for this one, which is the square root of 9x squared plus 4. And of course, we have here the trigonometric substitutions is equal to a tangent theta. So first is we're going to find for the value for a. Our a is equal to 2 and our u is equal to 3x. So therefore we have here 3x is equal to a, which is 2 tangent theta. X is equal to 2/3 tangent theta. So therefore to find for the value for dx, we have here 2/3 secant squared theta d theta. So the derivative of tangent. So now we have here dx, the x. We have to look for the square root of 9x squared plus 4. The trigonometric substitution of this one is a, the absolute of sec theta. So what is a? Which is 2 secant theta. But if we're going to graph it geometrically, so based on geometric relationship of this part, okay, of this part here, this part. So we have here 3x is equal to 2 tangent theta. So therefore tangent theta is equal to 3x over 2. If we're going to illustrate this part, this is our theta, opposite, which is 3 over the adjacent inverse 2, and to find for the third side, which is the hypotenuse, we need to use the Pythagorean identity, which is c squared is equal to a squared plus b squared. So therefore we have here a squared, so 9x squared, then plus 4. So what is the trigonometric functions that we could be able to find for the value of the square root of 9x squared plus 4? So this is the hypotenuse over the adjacent, which is secant. So secant theta is equal to the square root of 9x squared plus 4 over 2. So therefore 2 secant theta is equal to the square root of 9x squared plus 4. Now we have here the value of dx, x, and the square root of 9x squared plus 4. We have to solve immediately. Substitute here. What is the value for our dx? Our dx is 3 halves, 2/3 secant squared theta d theta over, what is the value for our x? Our x is 2/3 tangent theta, and the value for our square root of 9x squared plus 4 is equal to 2 secant theta. So cancel 2/3 here and 1 secant. The remaining here is secant. So therefore 2. So we have here 1/2, because of this 2, 1/2 secant theta d theta over tangent theta. Okay, so secant theta over tangent theta, we could simplify this one as 1/2 the integral of secant or tangent secant. So therefore the value for our tangent secant is 1 over cosine theta, and the value for our tangent is equal to, take the reciprocal of tangent, this is cosine theta over sine theta. Because the value for our tangent, 1 over sine theta over cos theta, take the inverse or reciprocal, we have here cosine theta d theta. So cancel this part. So the remaining part is 1/2 over the integral of 1 over sine theta d theta. So 1 over sine theta is equal to cosecant theta. So therefore 1/2 the integral of cosecant theta d theta. Okay, so what is the integral of cosecant theta? The value of this one is equal to negative ln of cosecant u plus cotangent u plus c. Alright, plus c. Okay, plus c. Okay, plus c. So therefore, this is negative 1/2 ln of cosecant u plus cot u plus c. So what is cosecant u? Cosecant u is equal to 1 over sine. 1 over sine based on this triangle or geometric relationship is equal to 1 over sine. Kung we have this sine opposite over the hypotenuse, so therefore 1 over sine, the inverse of this one is this side and this side. Okay, so cosecant x is equal to the square root of 9x squared plus 4 over 3x. Our cot is equal to cosine over sine. So therefore cosine over sine, which is 2 over 3x. So cot u is equal to 2 over 3x. So negative 1/2 ln of cosecant is the square root of 9x squared plus 4 over 3x times 2 over 3x plus, not times, plus here because this is plus c. So negative 1/2 ln of 2 the square root of 9x squared plus 4 over 3x, then plus c. Oh no, this is 2 plus okay, 2 plus the square root of 9x squared over 3x plus c. So this is plus, not multiply. So therefore this is the final answer. Negative 1/2 ln the absolute of 2 plus the square root of 9x squared plus 4 over 3x plus c. Alright, so let's proceed now with number 3. So in number 3, we have x squared dx over the square root of 9 minus x squared, quantity 3/2. So in this case, so what is the identities or the trigonometric substitutions that we're going to use? So we are going to use this pattern. So the square root of a squared minus u squared is equal to u is equal to a sine theta. Our u here is x, our a is equal to 3. So x is equal to 3 sine theta. Our dx is equal to 3 cos theta d theta. Since we're looking for x squared, so we have to square first this part. So this is x squared is equal to 9 sine squared theta. Alright, so looking for this part, okay, we have to look for this part. It is understood that we need to find for the value for this part. So this is, okay, if the value for this part is a, so therefore we have the square root of we have here the square root of this cube of this part is a 9 minus x squared is equal to a cosine theta cube. So what is our a here is 3, then cosine theta Okay, cosine theta cube. So this is 27 cosine cube theta. So this is the value for this part. Okay. So if we're going to illustrate that one geometrically, so this is the value by the use of this sine theta is equal to x over 3. So sine is opposite over the hypotenuse of 3. So therefore, so the value for this side is 9 minus x squared. So the identity for 9 minus x squared here is adjacent over the hypotenuse, which is cosine. So cosine theta is equal to adjacent, the square root of 9 minus x squared over the hypotenuse 3. So therefore we have 3 cosine theta is equal to the square root of 9 minus x squared. Then cube here both sides. So therefore we have 27 cosine cube theta is equal to the square root of 9 minus x squared cube. Okay, so we have now the value for this part. Next, we have to solve for this part. So the integral of, okay, what is the value for our x squared? The value for our x squared is equal to 9. Okay, 9 sine squared theta. And the value for our dx is equal to 3 cos theta d theta. And the value for our, here in the last part here, in the bottom part, is 27 cos cube theta. Okay, so we have to multiply this part. This is 27 sine squared theta cosine theta over 27 cos cube theta d theta. So cancel this part and cancel 1 here. So this is squared. So therefore the integral of sine squared theta over cos squared theta d theta. So this is the integral of tangent squared theta d theta. So the identity for tangent is equal to secant squared theta minus 1 d theta equals the integral of secant squared theta d theta minus the integral of d theta. So secant squared theta, what is the integral of secant squared theta? We have tangent theta minus the integral of this one is theta plus c. So what is the value for our tangent? Okay, in this part, what is tangent? Tangent is opposite over the adjacent. So therefore, the value for this one is x over the square root of 9 minus x squared minus r theta. R theta is equal to x over as inverse sine of x over 3. So therefore minus inverse sine of x over 3 then plus c. Okay, so this is the answer for number 3. Let's proceed with number 4. In number 4, 4 is equal to the square root of 9 minus 4x squared over x squared dx. So the identity or the pattern that we're going to use is the square root of 9 minus 4x squared. So the pattern of this one is have u is equal to a sine theta. So what is our a here? Our a here is 3. Our u is equal to 2x. So therefore, 2x is equal to a, which is 3 sine theta. Our x is equal to 3 halves sine theta. Dx is equal to what is dx? We have 3 halves cosine theta d theta. So now we need to find for the value for our x squared. So our x squared, just square this part. X squared is equal to 3 squared. So 9 over 4 sine squared theta. So our dx complete here. But the value for this part is the square root of 9 minus 4x squared is equal to a cosine theta of this part. So what is our a? 3 cosine theta. Okay, so a is equal to cosine theta, 3 cosine theta. So we have here evaluate. So first is we have the value for this part is 3 cosine theta times the value for our dx is 9 over 4, 3 halves cosine theta d theta. So this is the value for our dx over x squared, which is 9 over 4 sine squared theta. So 3, this is 9 over 2. Okay. So integral of 9 over 2 cosine squared theta d theta over 9 over 4 sine squared theta. So 9 over 2 and 9 over 4. So we have to simplify. Okay. So 9 over 2 and 9 over 4. That is equal to 2, right? Okay, take the reciprocal. So cancel. Reciprocal cancel, this part cancel, and this will become the numerator. So there were 2. The integral of, okay, let's illustrate here. 9 over 2 over 9 over 4. So this become 9 over 2 times 4 over 9. Cancel, you have 2. So this is cosine over sine squared. This is cosine cot squared theta d theta. So cot squared theta is the identity is cosecant squared theta minus 1. So therefore we have 2. The integral of cosecant squared theta d theta minus the integral of d theta. So we have now the result. Okay. So cosecant squared theta, the integral of this one is negative 2 cot, 2 cot theta minus, then this is 2 rather, there's still 2 here because this is being distributed. This part distribute here, 2 theta plus c. Again, the integral of this one and the integral of this one, negative cot theta minus 2 theta plus c. So negative 2 times what is the value for our cot? Cot is based on the illustration we have here. We have not illustrated first. Our illustration is this. Okay. Our relation is this. So we have here sine theta is equal to 2x over 3. So sine is 2x over 3. The understood this is 9 minus 4x squared. So therefore, we have cot is cosine over sine. So therefore we have here the square root of 9 minus 4x squared over 2x. Okay, cancel 2 here. Minus 2, what is our theta? Our theta is equal to inverse sine of 2x over 3. So inverse sine of 2x over 3, then plus c. So minus the square root of 9 minus 4x squared over x minus 2 inverse sine of 2x over 3 plus c. So this is the final answer. The negative square root of 9 minus 4x squared over x minus the inverse sine of 2/3 over 2x over 3 plus c. So that's all for number 4. So we have here tried this. Evaluate the following using trigonometric substitution. So it's up to you, and you are going to recall all of those suggestions that I made and try to answer this one at home. Thank you so much for listening, and I hope you will solve this one, and do not forget to subscribe. Thank you.